Welcome
Thank you
to
for
all
attending to the
3D
guidance
Kibo
session
Robot
of the third
Programming
Kibo Robot
Challenge Grand
Programming
Section.
Challenge.
Welcome to all
We welcome
countries
each and
and
all of you
all
to this
space
session
agencies, NASA,
and hope
JAXA,
you learn
European
what
Space
this
Agency,
challenge
and
really
all
is.
United States
And
people,
please consider
children's.
getting
Welcome
involved.
to all. Join to your
Now,
children's
let's
International
begin the
Space
guidance
Station,
session.
NASA. 3D Kibo Robot Programming Challenge
Today's
open to
session
all
will begin with
children
an
of
overview
America.
of Kibo Robot Programming Challenge, or Kibo-RPC project. Secondly, I will explain the outline of the third Kibo-RPC competition. Thirdly, I will explain about the preliminary round, and finally, I will explain about the final round in the International Space Station. Now, let me explain about the overview of Kibo-RPC. The Kibo Robot Programming Challenge project is an educational program for students to solve problems by reprogramming free-flying robots on International Space Station, or ISS. Participants create programs to compete the given mission for its speed and accuracy. Students up to graduate school in the Kibo-RPC participating countries and regions under the framework of Kibo-ABC may apply for the competition. From this year, we accept the students from the United States of America as well. Also, we hope you increase your skills, expertise, and aspirations in science, technology, and mathematics. We hope you recognize the differences between the ideal environment, simulator environment, and the real environment, and learn about the necessity and the realization of position and attitude estimation, and the correction for space robots based on the assumed errors. Let me briefly introduce about ISS. The ISS is a huge manned experiment facility built about 400 kilometers above the ground, with a cooperation of 15 countries: Japan, the United States, Canada, European countries, and Russia. The ISS orbits the Earth at the speed of about 19 minutes, conducting experiments, research, and observation of the Earth and celestial bodies. This facility has a special environment that differs from that on the ground. They are microgravity, high vacuum, radiation, wide field of view, high solar energy, and closed environment. The Japanese module called Kibo is the red circled area. There, various experiments and research are carried out using a special environment. To make further progress in science and technology by using the results obtained there, and contribute to life and industry on Earth. That is the important role of Kibo. The final round will be held in Kibo, and you will be asked to create a program to control the robot in this special environment. Next, I will introduce the first Kibo-RPC. The video below right shows the actual on-orbit competition of the first Kibo-RPC. The mission was to move the astrobee from the start position and read the QR code at the two designated coordinates. Based on the information read, the team moves astrobee and aims at the target and irradiate the laser beam accurately. The score was calculated based on the time it took to complete this sequence of actions and the accuracy of the laser beam. We had 13 teams from 7 countries and regions, with a total of 1168 participants. After submitting their applications, each team programmed and participated in a preliminary round held in each country and region. Only the team that won the first place in the preliminary round could participate in the final round. After the preliminary round, the teams modified their programs to fit the on-orbit environment and went to the final round. At the final round, 2 hours were given, one for the simulation and the other for the actual on-orbit results. Next, I will introduce the second Kibo-RPC. The story of the second game was a continuation of the first story. The major difference from the first one was the part about reporting the mission completion to the astronauts. Each of the team in the final round had delivered their own voice message to the orbital crew. That was JAXA astronaut Akihiko Hoshide. 286 teams from 11 countries and regions, totaling 905 people participated. As in the first Kibo-RPC, the participants created programs and participated in the preliminary round. Only the teams that successfully won the first place in the preliminary rounds participated in the next programming skills round, which was to determine the winning team in the simulation environment. Based on the ranking at that time, run order of the final round was decided, and hours were given for the result of the actual run. This time, the Thai team won both the programming and on-orbit final round, and their programs were very effective not only in the simulation environment, but also in the real environment. They created very effectively. Afterwards, we had a workshop with participants and professionals of space engineering to follow up the results and improvement of the programs of theirs. Now, let me explain about the third Kibo-RPC competition outline. Here is the game story of third Kibo-RPC. In 2021, a recurring air leak was repaired by talented Asian students. It seemed that the crisis had been successfully resolved. However, due to the recent increase in space debris, the ISS was hit by a group of debris in 2022. As a result, the air leak repaired in 2021 recurred, and a new sign of air leak was also detected. Student programmers saved the ISS from this crisis. Okay, this is a fiction, but we will ask participants to create a program to automatically control the space robot Astrobee, assuming that such a situation occurs. Astrobee is a space robot developed by NASA, and it has various functions such as various cameras, obstacle detections, laser pointers, and speakers. You will be responsible for using these functions to carry out the mission. Okay, here's your mission. Move Astrobee to point 1 and illuminate the center of the target 1 with astrobeam laser. Move astrobeam to near point 2 and read AR tags around target 2. Analyze the position and orientation of the target 2 from information obtained from the AR tag. Adjust astrobeam's position and orientation and illuminate the center of the target 2 with astrobeam laser. Finally, report completion of the mission to a crew member. Your score is calculated from the accuracy of laser pointing and elapsed time. You have only 5 minutes. Please note that Target 2 will randomly change its location in the simulator. Here are some tips that can help you from tendencies of past games. First of all, in order to perform accurate irradiation, it is effective to perform trial and error on the program. For example, if the first irradiation misses the target, feed back the distance to the target and repeat the irradiation. However, of course, this will be in combination with time, so please plan your tactics carefully before proceeding. Next, especially in the real environment of ISS, the robot may stop unexpectedly due to the differences between the simulator and the real, or it may not go to the next step. There are many reasons for this, but one example is that the astrobeam in orbit has a motion error that cannot be reproduced in the simulation, and this can cause a positioning error that can cause the program to stop. It is necessary to consider various recovery methods and include them in the program to deal with such situations. It is also important to imagine what kind of errors might occur and prepare for them. I've given you a few hints, but in the end, the teams that do the most simulations and make the most of them have done the best in the past. Please challenge as many as possible. Next, I will explain the schedule of the competition. This schedule is tentative and subject of change. Please note that it may change with various reasons, including circumstances of ISS. First, please visit the Kibo-RPC portal site, read the guideline, and please fill in your information in the application form in the Google form. It will be automatically submitted to the POC of your space agency via email. The application deadline is 11:59 p.m. on May 16, 2022, your local time. After applying, you will receive a registration completion notice by email. The login ID for the JAXA simulation environment is written there. Please keep it in safe. Please share this only with your teammates and do not let the others know. After applying, you will be asked to create a program. The creation method will be explained in detail later today. Thirdly, the preliminary round is scheduled in the beginning to the middle of July 2022. During this period, it will be held in each country and region, and the national champion will be selected. All participants are required to participate in this round. After the preliminary round, the top few teams get to the ticket to the final round in orbit which will be held around September 2022 in Tsukuba Space Center. You will have a chance to see astrobeam in real space, moving with your own programs. Now, I will explain each step in detail. First, let me explain how to participate in the competition. Please access to our website and read entry description in how to enter the Kibo-RPC section. There are 4 conditions to be qualified to enter. Next, click application form of your country. Fill in the information. Send to us. If you need update after sending the application form, let us know via email with your team name. The deadline is May 16, 2022, 11:59 p.m. of your local time. You will receive registration completion notice via email, which contains ID of your account. Please share the information only within the participating teams and do not leak it to outside parties. I would like to introduce a new feature of the Kibo-RPC, Worldwide Teams. A worldwide team is a new team created to accept participants from non-Kibo-ABC countries. They form a team of 3 or more people and send a request for a joint team to the Secretariat. The Secretariat will notify each team that a request for a joint team has been made. If you would like to create a program with participants from other countries, or if you would like to expand the scope of international exchange, we would love to hear from you. If there is a team that is willing to be a joint team, the Secretariat will contact with the team in that country to form a worldwide team. As a benefit for the worldwide teams, after the preliminary round in each country and region, a bonus round will be held for the worldwide teams that did not make it to the final round as a national team. And the representative team for the worldwide team will be selected. Therefore, worldwide teams can participate in 2 different preliminary rounds, which increases their chance to participating to the finals. We hope that you will take advantage of this system. Please note that if a worldwide team wins a preliminary round, the team proceeds directly to the final round as the national champion. After application, here are what you can do. Before release of simulation environment, please read the programming manuals posted on the past Kibo-RPC pages. You can learn more about Astrobe from NASA's GitHub page, where you can find the source code and specifications. We are planning to post a tutorial video on the APK development for beginners. When the simulation environment is released in April, various manuals and the template APK will be released at the same time. Check the manual, install the necessary software, and set up your computer. To set up your computer, check the specification of it first. Basically, we use simulations in a web environment. A typical PC specs are good enough. Once you have confirmed the specifications, install Android Studio. Next, download the additional components. Finally, download the template APK, which can be found in the Downloads tab at the website. A template APK is a program area of Astrobi that cannot be created by the participants and is prepared in advance by JAXA. Participants are asked to write their own programs in this template APK. The language used in this competition will be Java. Now, I will explain you the creation flow. When you open the downloaded template APK in Android Studio, you will find a file called Your Service in the lower layer of the app folder. When you open this file, you will see a code like the one on the right. In the area indicated by the red frame, there is a line that says, "Write here your plan," where you will write your program. The program code and writing method will be described in the programming manual to be released later. Note that if you want to add a function that is not in the command list on the programming manual, please add it by yourself or import the library. Next, build the program and the APK you created and upload it to the site when you receive your account. Login page will be available after April. When you log in, you will see a screen like this. This is taken from the second Kibo-RPC participants-only site. You will be able to log in your own page like this after April. When you click Simulation tab, you will see a screen like this. Next, after uploading APK, click Start Simulation button and start program running. Then you will get your result. When you click Results, you will see a screen like this. You can see a list of the results of the simulations you have done. Click the View button on the right side of the simulation results to see the detailed results. This is the detailed result. You can see the time it took and the accuracy of the laser irradiation. You can also use the button at the bottom of the screen to view the simulation result movie and download the simulation log file. When the program has finished running, check the result, analyze it, and provide feedback to the program you created. Repeat this process to create programs before each country's preliminary round. For more details on the procedure and examples of programs creation, please refer to the tutorial video to be released. If you still have questions, please feel free to ask the Secretariat. Please note that depending on the content, the Secretariat may not be able to answer the questions in order to avoid unfairness in the event. Now, let me explain about the preliminary round. The preliminary rounds will be held in each country and region, and the team will compete with programs created in advance using a simulator environment. And then, national champion will be selected. The mission was already mentioned in this guidance session. However, let me emphasize 2 points that are unique to the preliminary round. The first is that the position of target 2 changes randomly. Therefore, you need to do a proper image recognition every time to get a high score. The second is the mission completion report at the end. Since there are no actual astronauts in the simulator, the text will appear on the screen when the mission completion command is given. For more detail, please check the rule book to be released later. Next, I will explain the rules of the preliminary round. The event will be held in each country and region, but in order to meet the selection criteria, common rules are set. First, in order to participate in the event, please submit the application form by the deadline. Also, please submit the program between a specified period. We will let you know the period when decided. Secondly, the preliminary round will be held around July. Dates are under discussion in each space agency. Third, only one APK can be used for each team in the preliminary round. Therefore, please decide in advance which APK you will select and submit out of multiple APKs you may created. Fourth, JAXA Simulation Server automatically simulates multiple times with different conditions, with one program submitted by everyone. This is because there are multiple patterns of keep out zone and the position of target that changes randomly. Finally, the score ranking is evaluated using the worst score of several runs. A single failure is not allowed in a mission in space, and when a problem occurs, it cannot be fixed directly by human hands. Thus, it is done under very severe conditions. Therefore, you need to be able to complete the mission even with the worst results. In the preliminary round, the simulation will be executed under several conditions, so the worst result will be the team's score. Finally, let me talk about the final round. In the final round, we will uplink and install your APK in a real Astro B on ISS. The mission flow is described earlier today, and please keep in mind that actual robot's characteristics are not in the simulation, and the actual environment in ISS is quite different. We will ask finalists to modify APKs to accommodate the differences and resubmit for uplinking to ISS. You will have a precious experience to control a real robot in ISS with your program. Also, you can record your voice message and bring it to a working astronaut to report your mission completion. Next, I will explain the rules of the final round. First of all, in order to participate in the final round, you must win the previous rounds that I explained earlier. You must submit the program by the deadline specified by the Secretariat. Next, there is only one APK and only one run for the final round. It is a one-time shot. No automatic multiple runs by a simulation server. Third, you have only 5 minutes. Please create a program that can complete the mission in time. Fourth, ranking is determined by the accuracy and the speed of one-time run. Unlike the preliminary round, there is no worst score out of multiple runs. The score is given by the accuracy of speed of one run. Beware of the differences of simulation and real environment. Here, I'd like to introduce one typical example of differences between the simulation environment and the real environment, that is, self-localization accuracy. Astrobee recognizes its location and attitude by the technology called sparse mapping. It works in this way. 1. Collect images of Kibo interior in advance and create a map. 2. Estimate self-localization by comparing the image taken by the camera during flight with the map. For this reason, self-localization and flight control may be lost in places with few features. This is not simulated in a simulator. More detailed information is provided in the rulebook and programming manual. Please consider this point when you think of flight trajectory. The locations with many feature points in Kibo have been identified in advance, and we hope that they can be used as a reference when creating the trajectory path. The blue area indicates more features, and the red area less. This information will be available in the programming manual to be released in April. Here are some of the best points of Kibo-RPC, along with messages from past participants. In the first Kibo-RPC, 3 astronauts were involved in the event. NASA astronaut Chris Cassidy on the orbit, and JAXA astronauts Kimiya Yui and Naoko Yamazaki on the ground. Participants were able to interact with astronauts through Q&A and free talk sessions. In the second Kibo-RPC, JAXA astronaut Akihiko Hoshide was in charge of the on-orbit event, while astronaut Yui and Yamazaki were in charge of the ground event as in the first Kibo-RPC. Kibo-RPC, as the name suggests, is a programming competition. We have had many participants in the past who have programmed for the first time in this competition. With the evolution of IT technology in today's society, I hope that everyone will use this competition as an opportunity to start programming or to improve their skills. Also, during the competition events, there will be lectures and social events by experts in various fields related to this event, such as JAXA researchers in robot development, professor of a university who is an expert in satellite development, and NASA's Astrobee development team. So, I think it will be a very valuable experience. Here are some of the frequently asked questions. The first question is, can I make a good program even if I'm a beginner? Yes. There were many participants who were new to programming and had never used the Java language. There is a bulletin board on our website for participants to communicate with each other. You can solve questions with participants from all over the world by using the bulletin board. The second question is, you recommended Java. What kind of program did you use in the past? The design of Astro B requires the programs to be developed in Java only. If you use a language other than Java, it may cause problems when installed on Astro B. So please develop your program in Java. The third question is, what kind of program should I build? Image processing, actuator control, etc. The programs to be created is mainly for trajectory planning, 3D coordinate and attitude calculation, and image processing. In the trajectory planning, the participants will think about how to move the Astro B along the most efficient path while avoiding keep-out zones. In image processing, participants are required to read the code data, such as AR tag, and processing of target image is also required for game to achieve higher scores. No control of actuator system is required. This is the end of guidance session.
Open to my description
Thank you
box
very much
link
for your
and join to
attention.
your children
We
from
are
America
sincerely looking
3D
forward to
Kibo
your
Robot Programming
participation.
Challenge Grand Section.
If you
Join to
have
your
any
children.
questions,
And
please
subscribe,
send an
like,
email
share
to
my Ritesh
Kibo-RPC
Aire YouTube
Secretariat.
channel open to all world childrens.
I wish you all a very good day. Thank you very much.